Apple has officially launched the new MacBook Pro 14 and 16-inch models featuring the new M2 Pro and M2 Max chips. And we covered the announcement briefly in a recent video, but today we're taking a deeper look into the performance of the M2 Max using my personal favorite benchmark, video editing and encoding. Now, this is to get a sense of measurable real-world performance of the M2 chips, and not only are we going to take a look at rendering times, but we're going to compare them to the previous M1 Max. The M2, like the M1 before it, produces very impressive results, but as you'll soon see, the biggest gains are to be found in programs that can thread well across the increased core counts of the M2 Max. But first, let's look at what's new here. The key change is really in the processor. The M2 Pro and Max, we have the Max right here, improve on most of the central features. Apple claims 20% faster CPU performance with up to 12 cores instead of 10, along with 30% faster GPU performance. Now on the M2 Pro, you can get up to a 19-core GPU, while on the Max, you can go all the way to 38 cores, which is what we have here. The neural engine is now a reported 40% faster, and memory can now reach up to 32 GB on the M2 Pro and up to 96 GB on the M2 Max. Visually, the new 14 and 16-inch MacBook Pros are identical to their M1 predecessors, even down to the number of ports, display specs, keyboard, colors, and dimensions. Inside, though, is a different story, and this influences battery life and wireless protocols. For battery life, you're looking at a fairly modest bump across the board. On the 14-inch model, the M1 Pro or Max gets up to 11 hours of wireless web usage, whereas the M2 Pro and Max version get 12 hours. And on the 16-inch models, the difference is 14 hours and 15 hours respectively. This can likely be attributed to optimizing the power consumption of the hardware, which is still pretty impressive as there's an increased CPU and GPU core count across the board in the M2 series. Wi-Fi is now bumped up as well to 6E or 802.11ax, while Bluetooth is now 5.3, so you'll have support for the latest and fastest protocols, and there's an update to the HDMI port as well, which now features HDMI 2.1, bringing 8K output and multi-channel audio support. But anyway, what you're really here for are some hard numbers, right? My preferred way to benchmark is with video encoding, specifically exporting an actual video project that includes multiple effects, color grading, scaling, ultra-high resolution still images, motion graphics, and sound mixing as well. I also have some pure transcoding tests in here as well, but the reason I prefer real projects is because they can vary wildly in performance and show not only how the hardware itself performs, but how a program may be better or worse optimized for a certain platform. Adobe Premiere, and by extension Adobe Media Encoder, are very good tests for a few reasons. Premiere traditionally loves memory and raw CPU speed, and it will often shift resources from CPU to GPU and vice versa, depending on what's being rendered. Using a real video project we've previously edited featuring everything from 10-bit H.264 footage, 8K HEVC footage, 50 megapixel still images, color grading, and motion graphics, there's a solid and, more importantly, realistic mix of footage here that can be challenging to render. First, we did a ProRes render. The M2 and M1 chips are very unique in that they have dedicated hardware ProRes encoders built in, so they can create high-quality ProRes files faster than pretty much any other software-based solution. For a 12-minute, 23-second long source project, we managed to export a ProRes 422 HQ video in 4K in just 10 minutes, 7 seconds. That's faster than real time, which is incredible. Now, to put that into perspective though, since the M1 also has this ability, it's likely not that much slower, right? Well, yes, that's exactly right. The M1 Max, with the same project and the same settings, came out at just 11 minutes, 9 seconds, putting it just a minute slower than the M2. This is almost a 10% speed up with the M2. Next, I moved on to HEVC exports. HEVC is also hardware accelerated here, though it's still a slower process overall, presumably due to the increased complexity of the codec. Still, trust me, you don't want to encode HEVC in software if you can avoid it. Now, with the same project, exporting directly to a 4K HEVC file, Adobe Media Encoder finished in 17 minutes, 58 seconds. The M1 Max, meanwhile, took 24 minutes. That's a considerable 25% difference between the two. Lastly, on the Premiere side, I tried out good old H.264, this time in 1080p. I naturally expected this to be the fastest export due to the lower resolution, and you can probably see where this is going. 8 minutes 49 seconds on the M2 Max, and 10 minutes 44 seconds on the M1 Max. That's about an 18% difference, so not quite as striking as the HEVC example, but still very impressive. Before we draw any conclusions though, let's move on to Davinci Resolve. Resolve is a fantastic all-in-one editor, color grading suite, and even visual effects program, which means there are a few different workflows you can put the program through. But I wanted to perform as similar a test as possible to the Premiere test, which meant using a project of a similar complexity and length as our previous one. Luckily, we have some Resolve editors here, so I was able to render out an 11-minute, 20-second long video, complete with multiple camera formats, motion graphics, grading, speed ramps, and high-resolution still images. Just like before, we're starting with ProRes. I gotta say, Resolve really flexes its GPU-optimized muscles here. As it was going, I checked resource utilization and noticed a surprisingly small 10 to 12% CPU use, whereas the GPU was almost constantly at 80 to 85%, sometimes even 95% utilization. The resulting video rendered in a mere 3 minutes, 23 seconds. For 4K HEVC, it was a very similar 3 minutes on the dot, with similar resource usage along the way. For 1080p H264, an even faster 2 minutes, 46 seconds. But what about the M1 Max? The previous chip delivered very similar results of 3 minutes, 20 seconds, 3 minutes, 2 seconds, and 2 minutes 57 seconds respectively. These are neck and neck with the M2 Max, and in one case is even just a tiny bit faster, though we can probably chalk that up to margin of error. So what's going on here? Quite simply, Resolve is either not taking advantage of the M2's extra resources, or, and this is what I suspect, the process is already as fast as the throughput will allow it to render. Remember, these are processing at much faster speeds than the Premiere exports. It only takes about a quarter of the runtime of the video for it to export. And in case you're wondering, we rendered each video off of an external SSD running off USB 3.2 and onto the MacBook's own internal SSD, so there shouldn't really be any throughput bottleneck. I suspect that Resolve is basically rendering these things as fast as it possibly can, especially considering it was able to mostly saturate the GPU, but barely utilize the CPU. So for our last test, we're going to look at HandBreak. As a standalone encoding tool, HandBreak is an excellent benchmark because it removes most of the overhead of rendering the project itself, and instead can focus purely on CPU speed and hardware acceleration improvements, if there are any at all. I'll get back to that point in a bit though. HandBreak can use Apple's hardware acceleration here, so what I did was take the ProRes file that I created in Premiere from before and simply transcode it to 4K HEVC using as similar settings as possible to Premiere. Immediately, the CPU was almost completely utilized across every core, with the file finishing in 4 minutes 55 seconds. A similar 1080p H264 file test clocked in at 3 minutes 44 seconds. Now this is blazingly fast, though what was interesting to me was the GPU usage, or lack thereof. It seems that, at least as far as Apple is concerned, the hardware encoders are not considered a function of the GPU, and so GPU usage appeared to be non-existent. I can't say for sure though if hardware acceleration is even measured in the activity monitor, so you might not want to read into that one too much. Of course, you know I'm going to read into it. But before I do, the M1 Max turned out respectable numbers as well. 6 minutes 9 seconds for 4K HEVC, and 4 minutes 58 seconds for 1080p H264. So, what can we take away from all these numbers? First, let's just get this out of the way. If you're currently on the M1 Pro or Max, the M2 Pro and Max are more of an iteration on an already amazing processor. So even though there are some tangible gains here, those users can rest assured that their M1 spec MacBook Pros are still awesome machines. Now, on a more speculative level, the gains we do see here on the M2 Max are very interesting. Let's look at Davinci Resolve. The program absolutely crushes rendering tasks, and the attention to hardware optimization really pays off. But because of this, it shows that there is essentially a limit to just how fast these projects could render. Remember, and this is simplifying things a bit, video projects are essentially 2 stages. The edit itself being rendered, meaning color, text, effects, transitions, any scaling or position changes, speed ramps, and all of that. That rendered frame then gets ideally sent to the hardware encoder. So basically, each program has a different way of accomplishing that first rendering stage. This is important to understand because even though we didn't see any real difference in the Resolve rendering times, it doesn't mean that other, more intensive tasks couldn't benefit. There's GPU denoising, for example, or raw debayering that usually taxes any system. The extra GPU cores here could have been put to work on these kinds of examples, so do keep that in mind. Now on the Premiere side, we kind of get to see where the extra resources come into play. The extra CPU and GPU cores seem to give Premiere a slight but noticeable bump in every example. When examining the activity monitor, the overall CPU and GPU usage is very similar between the M1 Max and M2 Max, but the additional cores seem to give Premiere a slight boost here. You should know that CPU utilization never exceeded around 15 to 23% in any example, with most cases honestly dipping under 13%. GPU usage, meanwhile, was very dependent on what was being rendered at the time. When 10-bit H.264 source footage was on screen, for example, the CPU usage spiked while GPU usage went down, indicating that the footage had to be decoded in hardware. Conversely, when massive still images were on screen, GPU usage spiked to the 60, even mid-70% range, as Premiere relied much more on the GPU to perform those huge scaling operations on the images. Lastly, for HandBreak, the results are pretty straightforward. HandBreak will absolutely flood any core you throw at it, but it also uses the hardware encoders. This means that we can see the 2 additional efficiency cores in the M2 Max are carrying a little extra weight here and delivering faster results overall. The GPU isn't touched at all, which likely means that the CPU is being used for software decoding, audio encoding, and video scaling. It's thanks to the Resolve test's consistency, though, that we can likely infer that the hardware encoding block isn't being fully utilized. And that means that the improvements on the CPU side are even more impressive when using a program like HandBreak or even Premiere. Apple does claim that the media engine allows twice the ProRes performance, but given that we've only done a single ProRes export in all these tests, we likely didn't see this improvement in our tests. That's a lot to digest, I know, but just know this. The M2 Max improves on the M1 Max in nearly every way, and video editors, graphics professionals, music producers, and really any content creator who leans on professional software is going to get real, tangible benefits here. It's really cool to see the growth and the evolution of this processor line and how its unique design benefits certain programs and workflows. So that's it for this deep dive into the new M2 Pro and M2 Max. They're of course at the heart of the new 14 and 16-inch MacBook Pros. If you haven't upgraded to the M1 already, the M2 presents a serious maturation of the line with more software optimized for it and even faster performance overall. Let us know what you think of the improvements to the M2 Pro and Max in the comments below. This is Doug with B&H, and I'll see you next time.